Good morning, students. Today, good morning. Today we are going to discuss about the CO5 from Data Science and Analytics course. That is, analyzes the variances in the data using ANOVA. The level is CDL 2. First topic is chi-square test. The definition of chi-square test is it is a non-parametric statistical hypothesis test that is used to determine whether there is a significant association between the categorical variables, not a numerical, okay, whether an observed frequency distributions differs from our expected one. So we first point out the categorical variables. What do you mean by categorical data means? That is grouped into categories instead of numerical values. For example, gender as male or female, customer satisfaction yes or no, that means satisfied or not, the product choice A or B. So as per those the variables are considered as the categorical variables. Moreover, that is first of all introduced by the Pearson. So it is called as Pearson chi-square test, and it is used maximum non-parametric data, that is a categorical variable. And we are going to test the hypothesis test. Already we have discussed about the hypothesis test. It is two types, that is a null hypothesis test and another one is alternative hypothesis test. Assumes no effect or no relationship or otherwise no differences between the variables, in the sense we have set that is as the hypothesis H0, or otherwise it is set as hypothesis 1. Okay. So next, two different types of chi-square test are, first one is goodness of fit test, a single variable, and another one is test of independence. So the goodness of fit test, that is used to check how well the observed data. Here we are going to categorize two data, that is observed one, expected one. So how well the observed data matches the expected data based on a given assumptions or distributions. Okay. For example, here it is considered only single variable. So based upon the flavor, the observed data is considered. Based upon these calculations, we are going to find out the expected and chi-square value, etc. That's a goodness of fit. The goodness in the sense how will the observed data fit with the expected distributions. If it is fitted fully very close to the expected value, means that is called as good to fit. Next, test of independence. It is considered two variables. Test whether the two categorical variables are associated or independent. So that means two variables are considered here, whether two or more variables, whether it is or independent variables, that is no relationship between those variables, or otherwise are dependent variables, that means those are have any relationship with them. So these are considered, those types of variables are considered under the test of independence. So here you can see the first variable gender is the one of the variable, and the product category. Okay, these are the another one variable. So two variables are considered for the test of independence, and may find out the chi-square value of those variables. There's a quick comparison. Goodness of fit means we have considered only one variable. Test of independence means we have considered two or more variables. Okay. It is based upon the one variable, that is observed versus expected, that is a relationship whether the two variables are related or two variables are not related. So these are considered in the test of independence. Okay, what are the main use of chi-square test? That is used to testing the independence between the categorical variables. Already we have discussed in the last. Then goodness of fit also we have find out, and homogeneity also we have tested. That means checking if the same categorical distributions holds across the multiple groups. Then feature selection. In machine learning algorithm, the feature selection is maximum done using the chi-square test value, and also A/B testing also performed using chi-square test. Okay, these are the common uses of chi-square, and the importance in the sense, if you are going to work under the categorical data without requiring any normal distribution or numerical value, in the sense how we are going to categorize. how we are going to perform the test, how we are going to compare with the expected value and observed value calculations. That is maximum used in the various applications like medicine, social sciences, marketing, engineering, and also natural language processing, etc. Okay, why it is important in data science and analytics course? Because it is mainly used in exploratory data analysis process. For instance, that is used to determine whether user subscription tier is associated with a geographic region guide segmentation strategy. Moreover, already we have discussed, it is used in feature selection like machine learning, deep learning algorithms, and also that is used in A/B bar testing. That is, if you are going to design any user interface, in the sense if whether it is clicked or not, whether it is okay or cancel. So these are tested using the chi-square testing concept. Moreover, it is applicable in text classifications of that is natural language processing also. Moreover, the common comparison with chi-square test with the other test. So see that the categories are data type, groups, normal distribution, how the output statistics will become, and the typical usages and various tests. The chi-square is compared with the t-test, ANOVA, and reject test. So the main difference between these tests are based upon the categorical variables. So others are considered the numerical variables. The chi-square is only consider the categorical variables. Next, what are the procedure for calculating the chi-square and applicable in statistical processes? That is, the chi-square value is calculated using the summation of OI minus EI the whole square divided by EI. OI means observed value, EI means the expected frequency value, summation means sum all the categories. Okay, then expected frequency is calculated in two different types for goodness of fit, that is for single variable, another one independent test for two variables. Okay, if it is considered as two or more variables, means we have considered row total, column total, and divided by grand total, or otherwise goodness of fit in the sense we have considered only one variable. So total observation divided by number of categories calculation is enough. Okay, then procedure. If you are going to apply the any chi-square test, we have to follow the step-by-step procedure. As per that, first one is we have to set the hypothesis value H0 and H1. H0 means no association or no difference between the variables. If it is have any significant association between the variables, in the sense it is set as H1. Then the significance level value, that is alpha, is commonly set as 0.05. Next, the expected frequency, we should calculate the expected frequency, that is compute using the each category or cell using the appropriate formula. Already we have discussed in the above section. And also the fourth one is chi-square statistics is applied using observed value and expected, because observed value already given in the question. So as per that we have calculated the chi-square value, and degree of freedom, that is used to find out the independence of the categories. So it may be n minus 1 or row minus 1, column minus 1. So if it is a n minus 1 or k minus 1, in the sense it is a single variable. Okay, if more than two variables or two variables, means we have find out the apply this formula r minus 1 and c minus 1. Finally we have find out the critical value using the significant value of given percentage, and the final decision also taken based upon the calculated value and critical value. If the calculated value is greater than the critical value, in the sense it is come under the hypothesis of H0, or otherwise it is come under the hypothesis of H1. So now we are going to discuss about the example goodness of fit with a single variable. A candy manufacturer claims each of 5 flavors. Here the flavors are given 1, 2, 3, 4, 5. Okay, 5 flavors. 20% each, and 200 candy samples. So totally 200 samples are there. So if you are the observed value, they are given the value, and total is 200. Okay, then observed counts are below, and the hypothesis value is 0.05, but the distribution matches the claim. Okay, so the question is given with the flavor and observed value only, and the expected value. We should find out the chi-square value using the formula already we have discussed. Okay, so as per that we have find out 7.150. Okay, then we have to find out the degree of freedom, that is based upon the calculation of k value or n value. So if it is 5 means 5 minus 1 and 4, and using this degree of freedom value and significant level value, percentage value, we have find out the critical value of the using the table, chi-square table. Then the calculated value is 7.150. So finally what we have to conclude that since the calculated value is less than the calculated critical value, so we fail to reject H1. That means if the as per that, see, if the calculated value is less than the critical value, in the sense it is H1, so fail to reject H0. The observed quantity distribution is consistent with the manufacturer's claimed equal proportions at the 5 significant level. Okay, next we are going to discuss the test of independence, that is two variables. So here two variables are considered, that is one variable is gender, another one is the product type, electronics, cloth or food. These are the second variable. Okay, so same, but we are going to consider row and column total here for degree of freedom. Okay, and expected frequency table also calculated based upon the row and column totals divided by the grand total. So these are the row total, these are the column total, so final total is 300. Okay, then as per calculation, that is row total into column total divided by grand total, we have find out the expected frequency value for each product, that is for electronic product based upon male and electronic product based upon female, same as for clothing and food also. Okay, then chi-square calculation is calculated based upon the observed and expected value, and the calculation result is 18.643. So the degree of freedom calculated using row minus 1 into column minus 1. So the value is 2. So based upon the degree of 2, the significant level and the critical value is calculated from the table, chi-square table. Then the calculated value, the 18.643, is compared with the critical value. So based upon the calculation, our calculated value is higher than the critical value. So we reject H0. So there is strong evidence at the 5% level, the gender and the product preferences are not independent, both are not independent. So males show higher preferences for electronics, females are clothing. So these are the final inference of the given table. Okay. So finally what we are going to summarize as the male give the highly importance for the electronics items, not like female, because females are give the high importance to the cloth related products. Thank you.